In this lesson, we are going to begin eventually to talk about the derivatives of trig functions. But before we do that, we're going to go back to some limits real quick involving some trig. And here's how it's a little bit different is in the past, we would have had like a trig value over a trig value or something that we could manipulate a little bit and sub out and use some properties of trigs, trig identity types of things. But this time we don't. We have a trig value over something that's not a trig value on both of these. So we have some rules. We're not going into how these come about, but these are, if you're going to do the limit as x approaches 0 of sine x over x, you're going to get a 1. We're going to add to that because it's not that straightforward, because what if you have a number attached to it on the inside? So we're going to add a little bit to that. But basically, this value is approaching 0. This value is approaching 0, which does get tricky, and there are some ways to manipulate it. But right now, it equals 1. And then cosine minus 1 over x. This is going to 0. This is going to 1 minus 1, so you're getting a 0 over 0 again. Limit exists. But again, we're not going to go into how this comes about or how we manipulate it. But if you have that situation, it's going to equal 0. So let me add on the sine one in particular, that if you have the limit, when it does get a little trickier, for example, you have a sine of some value attached to the x, then the only way that this thing is going to equal 1 is that the bottom is going to need that same. So these two pieces need to be identical to each other for this to work. So with this one, right now we don't have a 4 on that x. So that's a little bit of manipulation that we have to do to make that happen. So not having a 4 here is not a big deal compared to not having. So like this, you can't really bring a value into this, but we can definitely add something to this. And so let's go into how we do that. So if we're doing the limit as x approaches 0, and our original problem is sine 4x over x. If I want a 4 on that, I'm going to multiply it by 4. But I also have to multiply the top by 4, because technically I'm multiplying by 1. So if I rewrite that, I'm looking at the limit as x approaches 0 of 4 sine 4x over 4x. And this is our piece that we wanted, right? That's that. So those values are matching. That thing is going to equal 1. So technically, we could pull this 4 out. And that way we can really have the property. Don't have to if you're comfortable with it, but you kind of want to make sure you see all the pieces happening. So that is that, which equals 1. So we're looking at now plugging the 0 in, essentially subbing it out. We're getting a 4 times 1, which is 4. Right? And then we have another one that involves sine, but this time they are different. So how on earth are we going to make this look like something like this when we don't even have just a variable, right? That's not involved in a trig. So we got some manipulation that we can do. First thing we can do is we can multiply this piece by 1 over x, which means we would multiply this piece by 1 over x. So let's give ourselves some space. So we're going to be doing now the limit as x approaches 0 of sine 3x over x over sine 5x over x. All right, so we brought in, we can multiply by anything we want as long as we're doing the same thing to the top and the bottom. So we're multiplying by 1 over x and 1 over x, which creates this, which gets us closer to what we're looking for. But now we kind of have to independently look at it. So we're going to manipulate this fraction by multiplying it by 3 over 3. And we're going to multiply this fraction by 5 over 5. And again, I'm just changing the look of it. I'm multiplying by 1, which doesn't change this overall value. Multiplying this by 1, which doesn't change the overall value. It just changes the look. And look is what we need. So limit x approaches 0. So now if I rewrite that, I'm looking at 3 sine 3x over 3x, to put that 3 with the x. So that's exactly what we're looking for all over. Same exact idea on this one. We got a 5 sine 5x over 5x. All right, so what can we do with this? So what we can do is, because it's a division, and maybe we should have done that at the beginning, is we can independently do this. So we can pull the 3 in front, and we can also treat the top and the bottom independent of each other. So sine 3x over 3x over the limit x approaches 0, pull the 5 off of this, sine 5x over 5x. So, so anytime you have a fraction or if you have multiple pieces added together, you can do the limits independently of every single one. So if I have a top and a bottom, I can do the limit of this and the limit of this as they're both approaching 0. So that way I have this perfect piece here, this perfect piece here, and I have a 3 multiplied to this, and I have a 5 multiplied to this. So this is just going to be a 3 times 1 over a 5 times 1, which is going to equal 3/5. So eventually there's going to be something to the fact that you have this look to it, not a coincidence that it turns into this final answer. Yes, there's stuff going on, but usually you're kind of asked to show and verify all those steps. But if you see a couple of them, you know what your answer is going to be before you even kind of really start. You're like, well, I know it's going to be a 3/5. I just have to show the math to justify that answer. All right, so that was doing some limits. Kind of dabbling with the little limits that didn't have trig values over trig values. We have a couple properties that we can use for it. And then eventually we're going to start doing actual derivatives with some trig stuff.